Students, this is Unit 3, Triangles. We're going to talk about Lesson 3.3, Mid-segment and Coordinate Proofs. Don't forget to get a parent or guardian sign-off or a teacher sign-off if you're in the SLC. Let's do some review first. I want you to find all possible angle measures in this diagram by yourself, then turn the video back on. Pause. Welcome back. Hopefully you found these completely on your own and you're just not waiting for me to give you the answers. That's how the brain works. It's called learning, folks. Ready? So if this was 46, a vertical angle, this would be 46. Then we can sweep a linear pair, which is out of 180. So I'm going to do 180 minus 46. I'm modeling what you should do. If you're doing two-digit addition and subtraction, you should do it by hand, folks. And we get 134 here and 134. And we're going to come over here. We're going to add 46 and 84. That's 130. Take it away from 180, and we get 50. There we have 90 degrees. Walk it around. Of course, this is 40. We're going to add 40 plus 85. We get 125. Take that away from 180. And we get 55. Then the last one, we can go like this. That's 180. We take away 84, and we're going to get 96. Hopefully you got that 96 as well. If you did, kudos. All right, with that review, let's see what we're doing today. So this is called mid-segment and coordinate proofs. And by the time we're done, you're going to be familiar with these terms. Midpoint, slope, distance, ring a bell, isosceles, congruent, parallel. Let's do a quick review. We're going to read the concept and then circle which equation you think could show it. Read this aloud with me. If you wanted to show that a set of segments were either parallel or perpendicular, which equation you would use? Which equation? Would you use distance, midpoint, or slope? You choose in 5 seconds. Parallel and perpendicular is a concept of tilt, so you would use slope. Slope shows things are either parallel or perpendicular. Let's try the next one. If you wanted to show that a segment has been bisected, then you would use which equation? Distance, midpoint, or slope? 5 seconds. Bisected means to cut exactly in half. So to show something's been bisected, you would use midpoint. If you wanted to show that the lengths of segments were congruent, which equation would you use? Distance, midpoint, or slope? 5 seconds. Congruent segments are things that have equal length, so we would use the distance equation. Let's see if you understand. I'm going to read these, We're going to do this one together, and the next two you're going to do on your own. It said, if we wanted to show on a coordinate plane, and anytime you think coordinate plane, you're thinking an XY grid. So these are things that involve a coordinate plane. They involve coordinates, X's and Y coordinates. If you wanted to show on a coordinate plane that opposite sides, so let's physically trace the opposite sides. That would be considered opposite sides. That would be considered opposite sides. If I wanted to show that those opposite sides on a coordinate plane were congruent in length, which equation would I use? In other words, I wanted to show that this side is congruent to that side in length, and that this side was congruent to this side in length. Choose. Would I use distance, midpoint, or slope? 5, 4, 3, 2, 1. It's not midpoint because there's nothing being bisected. It's not slope because slope is a matter of parallel and perpendicular. It's a matter of tilt. The issue of length is the distance equation. So if I wanted to show that this side was the same length as this side, I'd use the distance equation. Ready for the next page? You're going to do the next page completely on your own. Then restart the video when you are done. Pause. Welcome back. Let's see how you did. You should have read these and filled these out on your own. If you're watching the video and just copying, you are not learning. If you watched it on your own and now you're checking, that is a learning process. So I should see red pen corrections here on this page. If you're correct, smileys, star. If you're not correct, write yourself a little note about how to change it. So here, if I wanted to show on a coordinate plane that consecutive sides of a rectangle, consecutive, that means next to sides, were perpendicular. In other words, they meet at a right angle. If I wanted to prove on a coordinate plane, which would I use? Perpendicular is a matter of slope. It's a tilt issue. So you should have said slope here. You read this out loud. If you wanted to show on a coordinate plane that the diagonals of a rectangle bisect each other. In other words, they go through the middle. So the red cuts the green in half, and the green cuts the red in half. In other words, that is the midpoint of both segments both ways. I use the midpoint equation. So the most important thing for you to figure out is under which circumstance do you use the distance, the midpoint, or the slope equation. We're going to do an example together, but before we do, I'm going to introduce a concept about triangles. It says right here, in triangle PQR, mark D as the midpoint of PQ. So let's eyeball that, middle of PQ, and that's point D. And notice it's a midpoint, notice the hatch marks. And E is the midpoint of QR. Now we're going to draw a segment that connects D to E. Now I'd like you to physically trace DE, and now I'd like you to physically trace the side it's parallel to, which is PR. Trace those two segments. Now I want you to finger pinch them. In other words, start by putting your fingers right there at D and E. Now hold that distance and compare it to PR. And ask yourself, what is that relationship? There is a relationship there. In fact, there's two of them. Why don't you guess what those two relationships are? There's two things going on here. Let's see what we know. We had a midpoint and a midpoint. D, E, hatch mark, hatch marks. Ask ourselves again, what two observations can you make about DE compared to PR? There's two observations I'd like you to make. I'd like you to write down your predictions here. I'd like you to predict what two observations do you think is going on between DE compared to PR. I'm not going to fill in that blank for you. You need to guess yourself. It's okay if you're wrong, but I want you to think for yourself. Pause the video, write your predictions, restart the video. Welcome back. What you should have noticed, a couple things. The first thing is the fact, if you trace and extend, it's easier to see. The first is that these two segments are parallel. The second is the fact that DE is half of PR, or you could say PR is 2 times as big as DE. DE has a name. Because it connects midpoints, it is called a mid-segment. Now ask yourself, are either of your predictions correct? In the triangle below, D, E, and F are all midpoints. So D is the midpoint here, darken it, put hatch marks. E is the midpoint here, darken it, we're going to put hatch marks. F is the midpoint here, darken it, we're putting hatch marks. So that DE, EF, and FD are all mid-segments. We're going to read and fill out the summary below. Ready? Let's fill this out together. I'd like you to trace DE. Now trace BC. DE is parallel to BC. It's also half the length of BC. I'd like you to physically trace. The physical tracing helps your brain remember these relationships. We're going to trace EF. We're going to trace AB. It says EF is parallel to AB, which it is, and it's also half the length of AB. Let's do the last one, physically trace it. FD, CA. FD is, of course, parallel to CA, and it's also half the length. So all three of those mid-segments are half of the three sides they are facing. So the purple's half of this is half of this is half of that. Now we're going to use this concept on a coordinate plane. In triangle RFQ below, you have points R, and R is at -4, +8. Let's graph this. -4, +8. S is at 4, 4. And T is at 0, -4. We're going to show mathematically that the mid-segment created by the midpoint of RS, so we're going to have a midpoint of RS and the midpoint of ST, those two midpoints connected, that is both parallel to RT and half the length. Now you just can't graph that and say, oh, it looks parallel, therefore it is, and it looks half, therefore it is. Okay, you can't just say it looks like it. We're going to have to show it mathematically. So we have two qualities. We're going to have to show that that mid-segment is parallel, and that mid-segment is half the length. Parallel. We're going to use the concept of slope. Half of length, that's a distance concept. This is called a coordinate proof. You can't just look at stuff and say, oh yes, it has to be. You have to show mathematically. That rhymed. Let's try that again. You can't just say, oh yes, it is to be. You have to show it mathematically. Let's do our math here. Step 1. We are going to find the midpoint of R2S. Okay, so we're finding the midpoint from here to here. Let's get our coordinates. We have our coordinates. We write our template. Our midpoint template is add, divide by 2, add, divide by 2. Several of you put subtract on the most recent test. Let's circle our x's, plunk them in. We're going to box our y's and plunk them in. We're going to label and do our math. We're going to label this midpoint T. -4 plus 4 is 0 over 2. This is 12 over 2. So our coordinate for the midpoint is going to be 0, 6. We're going to label that midpoint D, which is right there. So D is at 0, 6, and it is a proven midpoint. Now we're going to find the midpoint of ST, going this way. We're going to make our midpoint equation. There's our template. We're going to circle our x's and box our y's. So 4 plus 0, that's going to be 4 divided by 2. 4 plus 4 is 8 divided by 2. So this ends up being This right here is -4. And so that's going to be 0. Taking a look here, of course, we end up with 2, 0 is our midpoint, and we're labeling that midpoint E, which is right here. So we have our midpoint D, which is at 0, 6, and our midpoint E, which is 2, 0. So we can draw in now our mid-segment. So now we have the math for our mid-segment. Our coordinates are this. This was 0, 6, and the coordinates here are 2, 0. Our coordinates here are -4, +8, and our coordinates here are 0, -4. Our first is we want to show that they are parallel. And to show things that are parallel, of course, we use the slope equation. So we're going to find the slope of DE, make our templates, and our slope of RT, make our template. I'm going to use one color for each. DE, it's y minus y over x minus x. So I'm going to box my y's. I'm going to go that direction and stay consistent. Circle my x's. Notice I draw an arrow to stay consistent. We're going to check our math here. 6 minus 0, that's 6. That's -2. We end up, that goes in there 3 times -3 over 1 is the slope of DE. Now we're going to find the slope of RT. Box the y's. I'm going to go this direction. This direction again. Double negative makes a positive. There we go. If you look very carefully, the slopes are exactly the same. So now we have proven mathematically that these two lines are definitely parallel mathematically, and the reason is they are parallel because the slopes are equal. You can't just say it looks equal. You have to show the slope. Okay, the second quality, not only is the midsegment parallel, it's also supposed to be half of the length. So to compare lengths, we're going to do the distance equation. So we're going to do the distance. Let's bring our numbers over again. D is sitting at 0, 6. E is at 2, 0. R is at -4, +8. And T is at 0, -4. First thing we're going to do is we're going to make templates for both. This is going to be our DE template and our RT template. Ready? It's x minus x, parentheses squared, plus y minus y, parentheses squared. So we're going to go ahead and do our x's. I'm going to circle my x's, be consistent in the direction. Notice I draw an arrow. Box my y's. Now we're going to do the math. That's -2 squared. We end up with the square root of 40. Now, because we have to compare lengths, and that's hard to do using radicals, We actually have to get a decimal here. So we're going to do 40 square root of, we get 6.3 approximately. Notice the approximate sign. Now let's check RT. Circle the X's. I'm going to go this direction. Box my Y's. That's -4, parentheses squared, double negative makes a positive. That's going to be 12 squared. That's 16 plus 144. You end up with the square root of 160. Now at first, that doesn't look like it's doubling. But you need to realize you're dealing with radicals here. So we're going to get the square root of 160. And look very carefully. It's 12.6. So if you compare these lengths, if we double 6.3, we get 12.6. So right now we have proved the second quality of mid-segments is that the mid-segment is not only parallel, but it's also half of. So the goal of a coordinate proof is to use midpoint, slope, or distance to prove something about a shape. Midpoint shows us the middle of stuff. Slope shows us things are parallel and perpendicular. And distance shows comparison of lengths. For the next class, very important, you must bring a compass and a straight edge. To the next class, you must bring your own compass and your own straight edge. If you really want to cement this information in your brain, set your cell phone for 2 minutes and talk yourself through the basic concept from the lesson. This is a great way to cement it for your long-term memory in your brain. Get out your cell phone, set the timer for 2 minutes, stop the video, start the timer, and talk yourself through what we learned today.